That's sweet.
Hi, everyone. Hello. Happy Sunday. Thank you for joining DataCon LA 2021. Welcome to the BI Reporting Business Use Cases track. My name is Delacqua Kester, your host, and your co-host is Hannah Yuda. We will be moderating the chat for questions and answers during the session. Today, we have a great guest today. His name is Chijioke CJ Ejimonda from Hybrid Data, and he will be talking about leveraging big data to maximizing value from rail and power infrastructure assets. Chijioke is the principal at Hybrid Data, a data-driven engineering technology consulting company creating niche products for real energy and infrastructure markets. Prior to starting Hybrid Data, he worked as a full stack developer, data engineer, and data scientist with several startups. Also, he worked as an electrical systems engineer on a rail transit project in Los Angeles, and as a reservoir engineer with ExxonMobil, helping support the execution of various energy projects. Chijioke earned his bachelor's degree in electronics engineering from Photo, and master's degree in petroleum engineering from USC. He's an aspiring marathon and soccer player, which I would like now to, without further ado, I'd like to introduce Chijioke for his speech. Chijioke, welcome to the stage.
Thank you, Delacqua and Hannah, for having me. I mean, that was such a great, introduction. But for today, I'll be very, very happy to have you all, dialed in, considering like the time of the day. We've all, had lunches, and I mean, this is like Sunday for most of us. This is almost like getting ready for the start of the week. But today, I'll be talking more about how we can leverage big data to maximize value from real and power infrastructure assets. And I mean, my plan during the entire presentation is basically to make this more like conversational. So if you have like any questions, as I run through the slides, by all means, I mean, flag myself or flag the host if you have any questions. So basically, why am talking about, leveraging big data to maximize value from rail and power infrastructure is because of the recent passage of the $1 trillion infrastructure bill by the United States Senate. I see like huge amount of opportunities, and I don't want only hybrid data to tap from those opportunities, but big data professionals. I mean, those involved within the rail industry and those also involved within the power industries, for everyone, to tap from. I mean, the amount of opportunities coming from it. As far as my presentations for today, I'll first of all give you guys a sense of feel of the different infrastructure project delivery models, and then give you a sense of feel of the different alternative big data sources that you can use in maximizing the value from rail and power infrastructure projects. Then last but not the least, introduce certain big data frameworks that help achieving batch and streaming analytics workflows, which are the typical workflows that are being deployed for delivering this infrastructure projects. So without much further ado, just to give you a sense of feel, there are numerous types of infrastructure projects. On the image you can see on the top left hand side is basically just a water pipeline. So a water pipeline for a city, for a community, or for a municipality can actually be an infrastructure project. On the top right, which is what I mean, one of the infrastructure projects we'll be focusing on today is around the rail infrastructure. So this gives you a sense of feel of the rail infrastructure projects that help power our society, that help move people and goods from an origin to a destination. On the bottom left is around the power infrastructure project. So power infrastructure projects, they could take the shape of, building, installing new transmission line, or installing what they call, electrical substations. It could also be around, the power generation plants. Last but not the least is it could take the form of dams. So, the dams could help, right here in California, it could help us prevent, the drought that we're experiencing by storing water. It could help us in also it could help in controlling flooding. And last but not the least, it could also help in generating power. But just to give you guys, a good sense of feel of, there are, even besides all what I captured on this slide, there's just like numerous amount of infrastructure projects. But we will focus mostly on the rail and the power infrastructure projects throughout this presentation. So heading to the rail and power infrastructure projects. So basically, to be able to deliver any infrastructure project besides the rail and power infrastructure projects we'll be focusing on, you need to go through different phases, which is the design phase, the build phase, the finance, the operate, and the maintenance phase. In the area of big data analytics, where we need like batch analytics to maximize value from these different phases is both mostly around the design, build, and finance phases. While where we need like streaming analytics to maximize value from the operation and maintenance phase. So first of all, I'll start up with sharing with you all where batch analytics, helps improve and optimize these different processes. First, I'll start with in terms of the currently whenever they people design rail infrastructure projects, they typically use census data, and census data is mostly being obtained within the 10 years frame here in the US and in the UK. So such kind of data, they are not granular enough. They can provide you the amount of huge insights that you want to generate. In other words, during the design phases when you build your travel demand modeling, and the census data can help you capture something like the different short trips that the commuters you're designing such infrastructure for will take. It can also help you infer what are their different travel modes. Are they traveling by foot? Are they traveling by bikes, or are they traveling by car? And also what routes are they going through? But with the help of the mobile device data, you can be able to best determine the position of the user. You can be able to determine, what modes they are traveling, and how much, how frequently they are traveling, with the mobile device data. So for the batch analytics for the power infrastructure projects, currently the kind of data that is being used for batch analytics are mostly like outdated data sets. And those outdated data sets, they lack the precise and the real world observations that we need to be able to estimate the amount of energy resource coming from, be it from a solar power plant or from a wind power plant. But with the help of satellite data, we can be able to collect hourly and even half hourly solar irradiance data and wind speed data to better, first of all, select the right site to install these power plants, and also properly design the infrastructures so that we can maximize the most amount of value during the design phase. So once we've been able to, design the the rail infrastructure where we want it installed, the next thing now is during the build phase, which is excuse me, which is during the construction phase, you're more or less trying to validate all what you've designed. And the only way you can validate is by, integrating actual real data to your models. And the actual real data you need for giving an example, like in the real scenario, you need equipment data, you need material data. Looking at the image I shared here, in terms of material data, you need this is what they call overhead catenary system. So it's basically a system that supports the overhead power lines that the train taps off in propelling the train. So you need to also integrate all these data sets. You need to integrate if there are like something like transformers or setting other electrical devices that power the system. You also need to capture all this numerous information to properly match all what your design or what all your design considerations. Moving to also like the power area. Now let's say, for example, if you've already designed for your wind turbine, right? Now you want to also integrate your equipment data and your material data. So giving an example of the image we have here, you in your design you might have stated what the actual hub height is, but now it's been installed. You want to be able to integrate what has been installed to ensure that all the power forecasts that you calculated or you estimated during your design phase, that they are all in tune with what you have installed currently. And with that, you can now be able to generate an appropriate turbine power curves, which will help you, more realistically estimate the amount of power that you produce. So the great thing about the finance model is that the finance phase takes its input from the design and build phases, but originally it takes its input from the design phase because it's from your design documents that you can be able to determine how much revenue you'll be generating from any infrastructure project. But during the build phases, there'll be like several different amount of changes that will occur that will alter your design. So you also need to integrate that into your finance model to accurately, forecast what your revenue streams will be at the end of construction of the infrastructure projects. So moving beyond the batch analytics, moving on to streaming analytics, the operation and maintenance phases of the project delivery model is where you take advantage more of your streaming analytics data. So for the real infrastructure projects, we'll delve more on like two parts. One, we'll talk about the power system section of the rail infrastructure projects, and also talk about the train system, because they are two separate systems that we can only leverage their real-time telemetry data to maximize the amount of value from the rail infrastructure project. So giving an example of, for something like a light rail or a heavy rail or a sub rail system, your power infrastructure could be made up of all what I captured here. It could be made up of your disconnect switches. It could be made up of your circuit breakers. It could be made up of your rectifier units. It could be made up of your transformers, your inverters. All these have like numerous sensors in them, and also actuators in them. Sensors for you to monitor all these devices to ensure that they actually they are operating optimally, and also the actuators for you to intelligently control them to prevent any, safety hazards or to optimize the system. So besides the power system, for the rail infrastructure project, the train system is also another key important piece, especially within the streaming analytics frame. The reason being that now your trains are running in real time, but you by um, by by combining the real-time streaming data you're getting from your train system and your power system, you can now be able to optimize the entire system. What I have on the slide here just gives you, highlighted in green, gives you a sense of feel of the numerous equipments on board the actual trains that contain current sensors to voltage sensors and all different kinds of sensors. So streaming data from both the power system and train system, you can now optimally maximize the most amount of value now that your infrastructure project is in operation. So moving on to the power system side of things, for example, let's say you already have your wind turbine facilities already installed. The great thing about the streaming analytics for the power system, for the power infrastructure projects, it takes the similar shape of the streaming analytics for the rail infrastructure projects power system. With these, um, you have like your transformers, which you can see here within the image, your circuit breakers. By being able to monitor and sense all this numerous equipment, you can be able to, estimate, the useful life of those equipment. You can be able to, determine if each and every one of this equipment, if either they are running on, either they are functioning abnormally, preventing the downtime of those equipment and revenue losses. Now we have a sense of feel of, the batch analytics and the streaming analytics within the rail and power infrastructure projects to give you a better sense of feel of, how can we use, our different big data technology stacks to maximize the most amount of to maximize the most amount of value. I'll be giving you all, a sense of feel of, the different big data stacks. So within the batch analytics framework, using something like your Apache Airflow, you can be able to model all these different, design phases, the build phases that I alluded to earlier, and also the finance phases. So, for example, let's say you want to model where what where to install your neural infrastructure for a particular community. You have about 10,000 people within that community. You want to know their origins and their destinations on a particular day. How frequent do they, traverse through numerous spots? What stations should you install? Having something like your Apache Airflow, you can model independently those different, the 10,000 those 10,000 people within that community. Now you can enrich that data set to be able to classify, okay, based on the frequency of this 20 or 30 individuals, this is the particular time of the day, they travel. What are their mode of transportation? So having a combination of your Airflow and your Apache Spark, you can be able to, model all of that during your and also your build phase. But last but not the least, after you've generated all these insights, right, you want to also store it into a robust and big data infrastructure, something like almost like your Hadoop Hadoop distributed file system. So within the batch analytics, big data analytics stacks, these are the three main stacks that we see that you can achieve the most value from. Then once you've now constructed the rail infrastructure, being able to now monitor and control, operate and maintain your power system that supplies power to your train system and also your train, you need now to move beyond just batch analytics to more streaming analytics infrastructure. Big data frameworks that we've seen that can really benefit from this is now this sensor data, this telemetry data from your numerous, power system and your train system. You can have like a Kafka broker that's streaming all this numerous, sensor data. Now, in the middleware, you have your Apache Flink, which can help you a lot more in terms of like your stream processing, processing your streams, enriching your streams, And last but not the least, for you now to generate insight to be able to determine the health, the status of all these different of your power system and your train system, or being able to estimate, I mean, the likelihood of failure of each and every one of the system. That's where something like, Spark comes into place to help us, generate those actionable insight that will be, beneficial and maximize the value of the operations and maintenance phase. In conclusion, what I want, every one of you to pick out from my presentation is that for batch analytics process, for big data batch analytics process, the design, build, and finance phases will benefit the most from it. Then for the big data streaming analytics process, the operations and maintenance phases will benefit from it. And most importantly, I hope we can all, take advantage of the 1 trillion worth of opportunities from the current infrastructure bill currently. That's all from me. Thank you. And I'll be happy to take your questions.
I had a question. In your experience, have you encountered like companies who wouldn't be like necessarily open to something as new as this? Maybe because it's new technology, it's not how they did things, so they are hesitant and kind of expanding or going in this direction.
That's a
Of big,
very good.
of
That's a
big data. Sorry, sorry to interrupt.
No, that's totally fine. I mean, that's a very great question, Anna. Um, you're right on it. So for this type of industry is dealing with, power and rail industry, um, they are a lot more not pro technology, right? But the reason I'll give it to them why they are that way is that, like, these industries I mentioned, the rail and the power industry, they're really sensitive industries. It's not just like typical, you're building like, a social media application. So little things, it's so critical, right? And the thing is, we're so happy and lucky, hybrid data, that a lot of people have talked about, how people can derive value from big data. So that helps, in educating them. And as you keep on educating them, the more they are open to, adopting, this type of technology. But they're both critical industries, the rail and the power industry, for example. So there'll always be that element. But what we've seen so far has been really promising and great. And we expect for there to be a lot more improvement and people wanting to adopt such technologies.
Okay.
No more
Any
questions.
other questions?
Probably going to ask everyone questions now. No.
Feel free to leave them on the chat or in the Q&A. Doesn't seem like it. What we could do is we could wrap up, but we could hang out.
Mhm.
Yeah, and see if there are any further questions. What would you like to do? Should we give them some time back?
Yeah, we could give them some time, but again, I have my email there. Anyone that has any question and they are shy to, share it here, they should always feel free to, shoot me an email, cj@hybriddata.us. It's something we enjoy chatting about, and I'll be definitely happy to talk more about it.
Oh, Dolapo, you're on mute.
I think you're mute.
I'm sorry about that. Apologize. Thank you for catching that. Thank you for that insightful topic or speech or talk,
Yeah.
and it was very engaging. I totally agree with you on all the innovation or data being leveraged on rail and power. In the past, we've always known things to be more solid state, not really anything that we can capture as of when it comes to data. You mentioned something about mobile data that you can be captured from, or records for the populace, consume not consumers but just citizens while they move around in travel, in transport, maybe rail or roads. Um, those data that you're capturing, though, are they from the geolocations of those mobile, devices, or like maybe Google Maps, something like that? How do you foresee how to track those types of data and help kind of project, either cities or states where infrastructure might be helpful overall?
So, great question, Dolapo. I like, you referencing, how, we can use, alternative like mobile data sets to properly, determine the right, route of the train, right? So we are not the ones capturing it. You mentioned one of the potential, I mean, not the potential, one of the those that capture such data, like, Google, right? Google captures such data. I think sometimes, I mean, talking about this within the transportation planning or transportation travel modeling, it seems like so obscure. So, give an example, within the ad tech world, right? How you're being served, contextual ads. Hey, we know Dolapo is, within this location at, they maybe enjoy this and enjoy that. It's just similar kind of the same data set. And just like, ads, the data, they're all anonymized. And it's just similar data sets that, people can use in maximizing the value of their design build phases of, I mean, the rail infrastructure, but it's not in, I mean, new data per se, right? Um, I hope hopefully that, kind of answers the question.
Yeah, it does. And I think you just use comparison comparison to like ad tech itself.
Mm.
Um, I was just wondering, many of those things. I think the authorities would like to know. Sometimes they have data, maybe sensors on of population and cities and how what they need and how to facilitate or improve infrastructure for them. But
Mhm.
it's good to have added, you know, data or information or parameter components to help facilitate overall picture. Yeah.
Absolutely, man. Absolutely. Yeah, it is. It is. And yeah, anyone that takes advantage of, that big, I mean, that's those data sets, they've always, ad tech has always been there for so long. And yeah, it's just more people, looking at how they could repurpose the data sets, already there, basically.
Well, great. Thank you so much, Chijioke. Thank you, everyone, the attendees, for listening and just participating on this talk. And if you have further questions, we would have a survey. Anna can talk more.
Right. There's a survey. Please provide feedback, and I'll put the link there. And thank you for participating in today's session. We hope you have a great rest of your day. And thank you for joining DataCon LA 2021. See you,
Thank you,
everyone.
everyone. Yeah.